Good afternoon, and thank you so much for joining the session. I will try to keep the tension high after the coffee break for this last part of the big Nextflow track today. So this session will be focused on about running Nextflow on Microsoft Azure cloud, but I would like to try to keep the session a little bit more high level, in general, talking about how the cloud can enable to accelerate Nextflow workflow in several different ways. I'm Wolfgang. I basically work as a senior product manager in Azure Storage Engineering. I'm focused on storage matters in engineering for everything that relates to HPC and AI, and naturally Nextflow is part of that. Co-authors of these works are two of my colleagues, Venkat and Jeremy, that work basically in Microsoft also very closely with many topics related to genomics and, of course, also to Nextflow. Let's say that the idea of the session today is basically to go, first of all, in understanding what are the benefits, what is the value added that the cloud can bring to Nextflow and to Nextflow workflows for researchers and bioinformaticians, and then talking about, at a very high level, what are the different architectural components of a Nextflow workflow in the cloud, and what are the different architectural components that are key to not only enable the execution of Nextflow in the cloud, but also what are basically the best selections in terms of storage solution, compute solution, and orchestration solution that can enable that. Of course, we will try also at the end to get a decision tree, kind of a guidance on what could be the way in which each organization may select what are the best components and the best strategy to go in an hybrid cloud or eventually even in a full cloud scenario for their workflows. Starting from the first part, let's say that as a background, I'm a mechanical engineer. I work basically in high-performance computing for now more or less 15 years. Recently, I've basically become very close to different research organizations that are basically running genomics workloads using Nextflow. So I started basically being very close to the problems, even if I'm not very close as of today to the research inside basically the genomics domain, but I'm learning pretty fast. However, what basically it's evident that the possibility of the basically that are happening in sequencing that are basically increasing both the throughput but also lowering the cost and also basically increasing the sequence lengths are basically constantly generating an increase on the required sequence, the required number of genomes that are sequenced year over year. And this, of course, translates directly on an increase of the core hours that are basically required for this type of workloads, for the data at rest, but also for the data that are in processing during workflow execution. And last but not least, we will have a session soon after mine about basically NVIDIA Parabricks, and also we had a session about ARM architecture. Different architecture are coming into the picture, bringing this type of benefit. And it's here that the cloud can basically provide, and I'm not talking only about Microsoft Azure, this is something that applies widely to the different hyperscaler, can provide benefits in terms both of infrastructure optimization, meaning that instead of making a huge decision every 3 or 5 years about basically what is the hardware that an organization selects for the research, there is the flexibility to change at a certain degree at any time the architecture and the dimension of the infrastructure, but also optimizing the way in which the workflows are executed. So basically for any task in your pipeline, you can potentially select a different configuration that basically can get the best performance at the minimum cost. Not less important, also what we see a lot is that when adopting the cloud, many organizations improve the way in which they collaborate, both internally and externally. we basically move from a scenario where the different researchers are maybe using their laptop or using some distributed cluster or servers that are around in the research institution to a scenario in the cloud where everything becomes more consolidated. And this, of course, gives better access to the data, better access to the pipelines, and a standardization of the way of working. And last but not least, all of this with flexibility, meaning that you can decide when to scale up, when basically to increase the footprint in the cloud, and if the research for a certain period is slowing down or requires less resources, you can, of course, reduce basically the cloud footprint. But having said this, being in the cloud doesn't need to be a big bang. There are different degrees starting from an on-premises scenario, an organization can go in the cloud. There could be the extension to the cloud of only some specific workloads, where basically there is kind of what we call a bursting scenario. There may be some workflow that basically are totally migrated in the cloud. And this could be the scenario, for example, where an organization, for example, is collaborating with other institutions, and basically there is the need of sharing in an efficient way large amount of data. Of course, having the data in the cloud and processing this data directly in the cloud provides a huge advantage in terms of cost and flexibility. Of course, there is also the full cloud scenario, but it's something that usually an organization gets there in a progressive manner. So going through a progressive hybridization and a progressive increase of the cloud footprint. So usually the best success is when basically this happens progressively, moving to a full cloud scenario in a gradual way. Having said this, we know that the different components of a Nextflow architecture are basically what are displayed in this slide. There is basically the compute and storage part, which is where the business logic of the compute and of the genomic data run. That is, of course, one of the first components. Then the second component, and this is something that, of course, many organizations already adopt on-prem, there is the presence of a scheduler that, given the Nextflow pipeline with all the different tasks, it's basically orchestrating the priorities and the resource availability of an high-performance computing system if the organization is already at that level. Of course, this is something that if you run pipelines on your laptop, of course, you really don't have a scheduling system. It's more basically something happening in a first-in, first-out approach. What is new, if you want, in a cloud infrastructure is the orchestration layer that sits on top of the scheduler. While on premises, you usually have a scheduler controlling a fixed number of resources, in the cloud, there is usually an orchestrator that keeps adapting the number of resources that you have deployed and that you have available for your pipelines in a dynamic way, in a dynamic fashion. This basically allows to have the maximum efficiency in terms of cost, so that basically you provision resources just in time, and you can also provision specific resources depending on the task you are running. And the integration with the cloud in the last two blocks is pretty transparent, thanks to the Nextflow executor, to the Nextflow plugins, because with minimal changes to the Nextflow configuration of your pipelines, you can easily plug your work without any major disruption inside a cloud orchestration. Basically, the user will keep submitting in the same way, just with minimal changes to their configuration file, and of course, in some scenario, also with some changes to how the data are basically become an input and an output for the pipeline. But in general, it's not a disruptive approach. Having said this, in terms of the different orchestration solution, if we now focus on Microsoft Azure, there are many Nextflow plugins and executors that can be mapped to the different orchestration solutions available in Azure Cloud. There are the most cloud-native one, which is basically Azure Batch, that works basically thanks, for example, to the Azure Batch executor. There are basically some cloud-agnostic one, if you want, like Azure Kubernetes services that basically can be enabled thanks to the Kubernetes executor. And last, for those organizations that are already using traditional HPC scheduler that can be Slurm, SandGrid Engine, LSF, the traditional executor can run, and this is very common in bursting mode in the cloud, thanks to a direct connection, for example, to an Azure Second Cloud cluster. Given this, moving to the second part, which is the compute, in the cloud, you have the possibility to define for each task of your pipeline what is basically the best VM types with minimal configuration to your Nextflow, minimal changes to your Nextflow configuration where you can define VMs with a specific compute and memory footprint depending on the requirement of each task of your pipeline. And this allows to get the best performance at the minimum cost at any given time. Also for storage, which is something that usually is overseen as something that is very static, very defined upfront, the cloud provides different possibilities. Usually in Azure, we refer to this concept of having a core storage layer that is usually an object storage where you have the vast majority of your data. You can scale up to hundreds of petabytes of data inside the core storage layer, and where then you plug just on demand on top of the core storage layer what we define the accelerator storage, which is integrated usually with the core storage and allows you to have for a brief period of time fast bandwidth and fast IOPS to access the core storage layer. And this maps to different solutions in Azure Cloud. You can see here that usually we have a core storage layer that is HDD-based, like blob storage, which is an object storage, Azure File Standard, which is basically a file-based solution, but is still backed by traditional hard drives, up to going to solutions like Azure NetApp or Azure Manager Luster that are SSD-based and go in the domain of being accelerator storage. All of this, again, in the direction of finding the best trade-off and the best balance for the specific needs of your workflow. Having said this, let's go and see what are some architectures that basically are realized on Azure, and these are all real architecture that are basically used today by customers that are in production on Azure and that are running today in Nextflow. Let's say that the most cloud-native one, if you want, and you can find similarity with other hyperscalers, is the adoption of a batch service that in Azure is called Azure Batch. Of course, this is the most cloud-native solution. It allows you to scale up to thousands of nodes if you want, but at the same time, has two implications. On one side, it's a huge disruption if you come from an on-premises environment because you switch to a pure cloud service where you have all your jobs run without user impersonation when all your data needs to go in a blob storage. For sure, it's the most scalable and the most cloud-native one, but at the same time, has also the implication that you get very specific to the cloud provider you are in. So in this case, you get basically very specific to the Azure Batch APIs that are used on Azure. Because of that, many customers prefer to have more cloud-agnostic solution. For example, what we have on Microsoft Azure is an implementation of the Task Execution Service API that is coming from the Global Alliance for Genomics and Health that basically runs in front of Azure Batch. So as you can see, as compared to the previous architecture here, you have an Azure Kubernetes cluster that is running basically an implementation of the task execution services, and that has the function of being an interface that basically totally decouples you from being tied to Azure in terms of a submission interface, but you are on a global interface that is implemented also in other hyperscaler and in other environment, giving you a certain degree of flexibility for everything that may happen in your future work. You can see also that in every slide there are specific links that we can, of course, then share on the Slack channels about click and deploy solutions that allow you to test in a very quick way these type of architectures. Another example of a more cloud-agnostic solution is the adoption of Kubernetes that, as you can see in a cloud scenario like Azure, can be connected directly to the Kubernetes executor. You can understand that since we are going in the direction of containerization and we're going more and more also in the usage of GPUs in the pipelines, Azure Kubernetes Services is something that is becoming more and more adopted by the customer. And at the same time, of course, we need to take in mind that some scalability limit of Azure Kubernetes services, like, for example, the number of nodes and the number of jobs that can be submitted at any given time, is relatively different of Azure Batch. So That can become one of the decision criteria, but at the same time, it also opens the possibility to use not only object storage, but also shared file system like Azure Manager Cluster, like Azure NetApp Files, that allow to have a more comprehensive selection of the storage solution for the workloads. Last one, as we mentioned, for those organizations that are that are still today relying a lot on classical HPC schedulers, like it could be Slurm, like it could be OpenPBS, like it could be IBM LSF, Azure Cycle Cloud is what allows to keep using out of the box this scheduler in the cloud in an hybrid scenario or in a full cloud scenario. This is also guarantees that your workloads will keep the portability on other hyperscaler without any major change. As a wrap-up for the session, let's say we created this decision tree, and let's say this is also basically in one of the poster sessions. Sorry for hacking this speaker session to be also a light-up session, but if you want, we can, of course, go into the details of that. You can see here what could be a decision tree to decide what is the orchestration solution and the executor to be picked up in the cloud for any given scenario. First of all, depends on where you are today and how much basically you want to be cloud native or you want to be cloud agnostic. Depending on that, and also depending if you have dependencies from your on-premises world, like a specific HPC scheduler, you can select the different solution that you can see there. But what is important to highlight, even if this is something that we're trying to work on Azure and it's something we are willing to expand, the different executors have different support for the different storage solution that you can find. So for example, Azure Batch today, at least in the open source version, mainly supports only blob storage and Azure File, while Kubernetes and Cycle Cloud can be plugged pretty easily also in a shared file system like Azure Manager Cluster. So all of this should be basically taken in consideration when selecting a solution to go into the cloud. Concluding the session, I would like to say so that the main takeaway is that the cloud can provide benefit to any organization for their pipelines, and this, of course, should follow a phased approach and a very ad hoc approach. There are organizations that are ready for a full cloud scenario, organizations that can take advantages only on from a partial hybridization. But what is important is that based on that, then there is the possibility to select those cloud architecture that gives the best cost-performance blending and the best benefits for all the researchers of that organization so that they can get the maximum performance at the minimum cost, of course, accelerating the throughput of their research. Thank you so much for your attention, and I don't know if you have any question. I'm really willing to answer that.
Thank you so much, Wolfgang. Do we have any questions from the audience? One question that I'd like to throw out is, what of those different architectures that you highlighted are the most common among the companies that you guys work with?
Yeah, so let's say that I would mention basically two as of today that we see a lot. Let's say we see a lot the Azure Cycle Cloud one, so those organizations that are coming from an on-premises scenario where they have their scheduler on-premises and they've built many of their data lifecycle and many of their workflow lifecycle around that. This is something we see a lot. But we see a lot also Azure Batch, where there are those organizations and institutions that take a more brave approach. Let's say we go in the cloud, we go full-blown, we rewrite everything to go in Azure Batch. These are basically kind of the two extremes we see, and that are also the most common one.
Okay. Thank you so much, Wolfgang.
Thank you. Thank you, everyone.